Faradays and Lenz's laws, E. This figure shows a conducting loop moving toward a region of uniform magnetic field. Circle the correct answer for each quantity. The induced current in the loop as it enters the magnetic field. When this loop enters the magnetic field, right now you see there is no magnetic flux through the loop, and as it goes into the field, then the magnetic flux through the loop will begin to act into the page. Lenz's law says that we want to fight that change in flux. And if there is an increase in flux into the page as this loop enters the field, then we're going to fight with our thumb. We're going to point out of the page. And so we're going to get a current that goes counterclockwise around this loop. When this loop is in the field and it's traveling within the field, the flux isn't changing. There's not going to be any induced current. Now, what about as the loop leaves the field? Let me just draw a picture. There's the loop, and it's leaving the field right there. Prior to this, we had all kinds of flux downward. And as we leave the field, now you see there's less flux into the page. And what does Lenz's law say? Lenz's law says, I don't like change in flux. If the flux into the page is decreasing, we're going to use our thumb, we're going to try and help out, and we're going to get a clockwise current in this loop. Let's go back here. We're going to start with the loop down here. We're going to do this again. Now we want to know if there are any forces on this loop as it enters the field. Somehow it's moving, but we want to know if there are any forces that come into play. We said just a second ago that when we were entering the field, there was a counterclockwise current around the circuit. That means that, let's look at this top portion of the loop, and there's a counterclockwise current, which means it's going to the left this way. These charges right here, when they get into the field, they experience what kind of a force? Well, let's use the pat-pat right-hand rule. The charges there are moving to the left. We'll put our thumb there, and they're in the presence of a magnetic field that is into the page. Charges moving to the left, the field is into the page. Sorry, my fingers are going into the page, so I'm patting down. As this thing is moving up, there is a downward force. There is a resistance to that loop going into the field. When the loop is in the field, there's no current, and there's no resistance to that loop just moving right through the field. Now, as this thing exits the field, let me draw that loop right there, and it's exiting the field. And we said when it's exiting the field, there is a clockwise current, which is going like that. So let's just look at the charges that are moving right here. Those charges through this portion of the loop are moving that way. And if we use the pat-pat right-hand rule on that, we put our thumb in the direction charges are moving, we put our fingers in the direction of the field, which is into the page, and once again, there is a resistance downward.